Hi, everyone, and welcome to today's session. My name is Corey Dow, and I'm a Principal Technical Marketing Engineer with HPE Aruba Networking. And today we're going to cover an update for AOS-CX release 10.16. Feature is called Route Target Rewrite across fabrics. Today we'll cover the typical agenda that we normally do for these transfer of information sessions. We'll have an overview followed by use cases, details, and caveats, the configuration of the feature along with best practices and troubleshooting, along with a demo and additional resources to help you find the information you're looking for. Okay, and so for an overview of the feature, we're going to just start by revisiting what we've already released with AOS-CX 10.15. Back with that release, we supported route target rewrite across fabrics within the configuration where you have both a 2-byte ASN on both sides. So this is a multi-fabric setup, as you can see here, with ASN 65100 and 65200 across the fabric with a eBGP. And so we supported the route target rewrite, as you can see in the configuration here, where we introduced two commands in that release: route target auto mode legacy, as well as the neighbor context here where you see replace RTASN. And as the information in this review presentation covers, it's what happens is we take whatever the ASN that it's coming from and end up rewriting it as it crosses the fabric. So say traffic from say VM2 or VM1 going across the fabric to the other side, then you're going to see that that route target is going to get rewritten from the ASN from that ASN perspective. So as we see here, leaf one is rewriting the original ASN is coming from 65200, but we're rewriting that as 65100 for really the sole purpose of helping to alleviate having to have these manual route target configurations, as you see down here for VLAN 10. These are now eliminated where you don't need this any longer. You can just use the route target auto mode legacy command. And so this works with 2-byte ASN. So we didn't have support for 4-byte ASN, and we'll go into more detail as we move through the presentation, but that's one of the big things that we're adding with the 10.16 update. And so from additional information, you can see we've got the elevator pitch here, as well as the detailed transfer of information for the original release for 10.15, and I've provided you just some snapshots below here so you can go find that information for review purposes. So again, so with 10.15, so we supported a route target auto with 2-byte ASN prefix and 2-byte or 4-byte suffixes, and you'll see what that means as we go further throughout the presentation. Okay, before we dive into the details about what we've actually changed with 10.16, just helpful to do just a brief review of the ASN format, as I just mentioned on the prior slide. So the 2-byte ASN format, it looks like you see on the left-hand side here with the 65100 ASN, and so that's a 2-byte designation for the autonomous system reservation, and this is covered in RFC 6996, as you can see here. And so that supports ranges from 64.512 to 65.534, and that's reserved for private use in the 2-byte range. But we also have environments that are supporting the longer byte format as well. Specifically, other multi-vendors support the larger 4-byte ranges, and you can see the range goes from, I'm not going to read the long numbers here, but 42xxx up to 429. And so this is reserved for private use in the 4-byte range. And you can see the ranges that are covered there. So like 65536 in this example is actually a 4-byte ASN because it's out of the 2-byte range, as you can see listed here. And so this is just here for your reference. So this is a multi-fabric setup with two different ASN formats. And not to say this is all that common, but we do run into this in some data center environments. So we do need to accommodate for this, because when you have the 2-byte and 4-byte autonomous systems, there needs to be a mechanism in place so that they can coexist. And so in this example, the 65536 ASN is in 4-byte format, but the 65100 eBGP peer ASN is in the 2-byte format. So without having a way to automatically map these, you'd have to use the manual route target imports, which was supported previously with 10.15, but we're going to handle the automatic way of doing that with 10.16 now. And as for platform support, you can see the features that we've introduced back with 10.15. So this is just a review of what we had already released. So we have the two features here, the EVPN via VLAN route target auto mode legacy command, as well as the EVPN replace RTASN feature command. And so these are supported in the platforms that you see here, the 8325, 8325H, the P, 8360, and then the data center platforms that you see here. So, and they're also covered again in the YouTube examples that I have up here for the elevator pitch and the deep dive sessions. Now, what we've introduced with 10.16 0001, which is the starting release for this feature, is so we still support the two features that we did in 10.15, but we've also extended that to the other platforms that you see here with 10.16. In addition to covering some additional platforms in the 10.15 release here. So you see we've really covered most of the platforms now as far as this feature is concerned. And then we've also introduced this route target import star VNI feature. So this is new to 10.16 across the platforms that you see here, and we'll get into more details about what that actually does. So additional platform coverage. What we'll see is we support now 2x and 4x ASN interoperability, introduced with the RFC 4893 support. And then the new VRF route target auto VPN feature is introduced for imports and exports, and you'll see what that looks like in the configuration. Just one word of note, the 10.16 0001 is a limited platform release, not really GA. It's being released to a few beta customers initially. The official GA release will be the 10.16 1000 release that's coming out this summer, so just be aware of that. Okay, so just a review with an example of what we did with the L2 VNI support for 10.15. So as you can see on this right-hand side, we just got an example here with just a L2 VNI 10 that maps to VLAN 10, as you see here, with two different hosts that are stretched across the fabrics, between the two borders that you see here between Border Gateway 1 and Border Gateway 2. And they represent the 2x ASN cases. So these are all 2x ASNs. And so just some reminders. So this is useful with the multi-fabric data center deployments. It's not relevant for single fabric because with single fabric, as a reminder, this ASNs would all be the same. So there wouldn't be any need to change it. And I've already mentioned the stretched L2 VNI between them. And so all the peering, also mentioned that, is done with the 2x ASN assignments. And so what this provided was just better usability, as prior to 10.15, everything required manual route target imports. And as mentioned previously, just better interoperability in mixed vendor data center environments. And this may also apply to campus environments. However, IBGP is more typically found when we look at campus environments. Okay, and extending the prior example, you can see what we're doing now with 10.16. It may not be so noticeable, but we're taking the 2x ASN, so we've maintained that on the left-hand side for this environment. And then in the other fabric, we've got 65536. So this, again, represents the 4x ASN format. So to be able to do route target imports automatically, we needed to introduce some new features for this. And so this is just at the L2 VNI stretch VLAN case. But what is new is the support to be able to do route target imports with an EVPN between different ASN number representations, as you see here. And the same customer benefits that I mentioned on the prior slide. Okay, and same as the slide previously, but just demonstrating that now we're also, in addition to just a stretched layer 2 VNI, we also have an L3 VNI now that is supported for automatic route target imports. So we've got an L3 VNI here for VNI 1000 that corresponds to the Leaf 1's VLAN 20, or I'm sorry, VLAN 10 SVI. And then on the opposite side for Leaf 2, there's an SVI for VLAN 20 so that they use the L3 VNI to be able to communicate across the fabrics between these two networks. And as to the details for this route target import star.VNI feature, so again, it helps with importing routes based on the VNI. irrespective of the AS number that the peer is actually in. So configuration commands introduced as part of this feature. As you can see here, the auto option is added for VRF route targets to support the auto generation, or auto RT we'll also call it. So this isn't required, but it simplifies the configuration because it eliminates the need for manual route target assignments. And so with this feature, the route targets will be auto-generated based on type 0 RT, which is in the format, as you can see here, ASN colon L3 VNI format. And so there's 8 bytes in total here. So the 2 bytes and the 6 bytes, that the 2 byte is set to just 00 just by standard, and then the 2 byte ASN or the 4 byte in the 2 byte ASN plus the 4 byte VNI is shown here that corresponds to the 6 bytes that we see. And so what happens with this, as mentioned in the 4893, SLC is for the 4 byte ASN value 23456 is AS trans that's mentioned in the RFC, and it's used to auto generate this route target. And so as an example, for an ASN value of 65536, which again is a 4 byte format, with VNI 1000, the route target generated will actually be 23456 colon 1000 per the standard. And the granularity, as you can see, is per BGP neighbor. And as a result, it's applicable to all L3 VNIs and L2 VNIs for which the routes are received by the neighbor. And as to caveats or things to watch out for, so you want to watch out for a mixed bag of configurations, including manual and auto RT, as that's not supported. So when you do that, you'll see a message when you go to configure replace RT-ASN that'll give you a warning that you've got a manual route target assignment somewhere within the configuration. So you want to make sure that that doesn't happen. Otherwise, you're not going to be able to import the route target successfully, and you won't be able to communicate across the fabrics. Okay, so let's just take a look at what's new underneath the hood. So this is the stretched VNI case, as you can see here. So we still have the L2 VNI with VLAN 10 that's stretched across the two fabrics. And so the new aspect to it is the replace RT-ASN in coordination with the auto mode legacy is used to automatically import the routes. And so this wasn't available in prior releases where there was 2 byte ASNs across the board, then that was supported. But now with 10.16, we also support the 4 byte ASN as well. And so as we kind of mentioned on the prior slide, you can see what happens from each of the leafs perspective once they're imported in. You can see that on the left-hand side, leaf 1 is in 2 byte format already. So you see that the route target is replaced with its own ASN 65100:10, corresponding to VNI 10. And then on leaf 2, on the opposite side, you can see that the route target is imported as 23456:10, which is new by the standard, which allows that to be translated from what would originally be 65100 over to 23456, so that the 2 byte and the 4 byte formats can be used to import the route targets automatically. And so this does require that the route target auto legacy be configured across, each of the peers in the environment to get the route targets imported successfully across the EVPN fabric. Okay, on this slide, it's similar to the last slide where we have a combination of the 2 byte and 4 byte ASNs in the environment between Fabric 1 and Fabric 2. And so what's new, as you can see, just designated by the new little icon there, is that we now support this route target export auto VPN, EVPN, both the imports and the exports, to get these route targets imported automatically. So these would be configured across, each of the devices in the fabric. So as you can see here, so for the VRF red VRF, so we have the route distinguisher uniquely identified across each of the borders as well as the VTEPs. And then we're using the replace RT-ASN feature to import that route automatically. So you have to configure it within the VRF context, as you can see here. And you also have to have the replace RT-ASN that we've configured in prior releases to get this to work correctly. And just like you saw with the L2 VNI use case, you can see the same thing is true here. So leaf 1, we've imported the routes with its own ASN, so 65100:20, and then also 65100:1000 is getting rewritten once it enters border gateway 1, and also at VTEP 1 as well. And then correspondingly on the other side, as you can see, so we've got the replaced RTASN configured for each of the peers. And then this gets rewritten, as we can see here, even though the ASN is actually 65536, underneath the hood, it rewrites it as 23456:1000, which corresponds to the L3 VNI, as we can see here. So it's shown here, but the route target auto mode legacy is needed or required for the L2 VNI cases, but it's not necessarily required for the L3 VNI use case. So if you wanted to use the 2-byte ASN with a 4-byte suffix that we introduced in 10.15, that would work as well, and we have an example of that working in the demonstration later. Okay, so as for best practices, you want to make sure to configure the route target auto mode legacy and the replace RTASN features together, specifically when we're talking about the L2 VNIs, so that the targets can be automatically generated. So you want to maintain consistency with the devices that you have across the fabrics, as mentioned here in the second bullet. So for troubleshooting, it really boils down to a number of show commands that you can see here, and you'll see a snapshot of those in the upcoming slide. So you do show EVP and EVI is here to determine which mode is used for the auto generation of the route targets. You know, whether or not you're using the 2-byte ASN with a 4-byte suffix, you'd use this command to determine that. You'd want to look at the show BGP L2 VPN, EVP and external community. So these track down the actual route targets that wouldn't just be shown if you didn't add the external community command. And this will show you specifically where the routes are getting rewritten. And we actually showed a couple examples of that also already. Some additional notes here. So changing the mode from legacy to default doesn't require BGP session restarts, but the configuration needs to be consistent, as we already mentioned, or the correct route targets will not be imported. You have to use the clear BGP star command. If you add any of the replace RT ASN configurations to any of the peers, you have to use that command to get things active again. And what happens when things aren't correct? Basically, you won't get tunnels established, and the MAC addresses won't be added to the MAC table. The routes won't be existing in the VRF that you specified. So additionally, you want to check the routing table per VRF to make sure you've got the routes are all imported correctly. You want to definitely make sure that the virtual MAC configuration is present on all VTEPs, and this is the case where you do have an L3 VNI. Otherwise, you'll have connectivity issues across the L3 VNI, which I actually ran into myself. Okay, so this is just an example of the show EVP and EVI command. So we still have the 2-byte ASN and 4-byte ASN in each of these corresponding fabrics, as you see here. And so we're just dumping the show EVP and EVI output on both leaf 1 and leaf 2 to see what we end up seeing here. So we've configured the route target auto mode legacy. So that's going to use the 2-byte format with the 2-byte suffix, as you can see here. So we've got traditionally what you'd expect to see here. So 65100:10 corresponding to VNI or VLAN 10. And then for the L3 VNI, as you see here listed out. So 65100:1000. So leaf 1 is rewriting that from what would have been the original ASN coming from the other side, 65536. And then on leaf 2, as I've already mentioned here, so we've got the route target auto mode legacy configured here as well. And so we're just dumping this table as well. And so you can see the imports as mentioned here. So 23456:20. So we're rewriting that from the what would have been the original 65100. And the same thing for the L3 VNI, as you see listed out here, along with the route distinguishers. And this is the example of what it looks like when you omit the route target auto mode legacy command, as you see here in the EVPN configuration. What we end up seeing is the 2-byte ASN with a 4-byte suffix, as you can see represented here, that's auto-generated. However, the L3 VNI, as you can see here, doesn't have a 4-byte suffix. It still uses the L3 VNI corresponding to the ASN here, which is still rewritten on both Border Gateway 1 and also Leaf 1 itself. And then correspondingly on the other side, as we mentioned for the L2 VNI 20, so you see 65536:20 here. And then for the L3 VNI, the 23456:1000 that we mentioned that it's getting rewritten. And again, just from the troubleshooting perspective, we're going to dump the show BGP L2 VPN EVPN external community command. And as you see here, so for Leaf 1, we can see the external communities for each of these. So we see how it's getting rewritten. This is the only place to really kind of see this. So you see 65100:20 as well as 65100:1000 that corresponds to these MAC and IP entries coming from Leaf 2 on the other side. And then correspondingly, so on Leaf 2 for the entries coming from Leaf 1, we see how they're getting rewritten with 23456:10, which is VNI 10, and then :1000, which is the L3 VNI, as we've seen already. And continuing our troubleshooting, you can see we're just dumping some additional show commands here. So we're going to dump the show IP route VRF, which is the overlay VRF. In our case, it's actually VRF red. Has the interconnected subnets for both VLAN 10 and VLAN 20. So we're dumping the route tables here, and we can just see for VRF red that we see the correct entries here for the 10.110 network as well as the 21.110 network on both sides. And also pointing to the correct next hop, which in both of these cases on Leaf 1 and Leaf 2 just point at the border VTEPs, as you can see here. And for the demonstrations, we're just going to highlight in the demos both of the topologies that we showed and discussed earlier here. So the L2 VNI stretch across EVGB peers using a VLAN 10 and mixed 2-byte and 4-byte ASNs. And then the same thing also is true with the L3 VNI 1000. Okay, so we're going to start off with the demo that just corresponds to the L3 VNI, because that's kind of really what is new mostly with 10.16. So just I've got, just for orientation purposes, I've got a Border Gateway 1 up here on the left-hand side, Border Gateway 2 on the right, Leaf 1 in the middle section on the left here, and Leaf 2 on the right. As you can see, we've got the labels here for them as well as the two hosts that you see here that are 10.1.1.10 and 20.1.1.10, matching the configurations for VLAN 10 and VLAN 20 across the L3 VNI. And so we're just looking at the BGP configuration across the board. So we can see that we've got the replace RT ASN. So this is a neighbor 7777 is Border Gateway 2. And then corresponding on the other side is neighbor 6666 for the replace RT ASN as well. And so we can see the BGP as well. So the neighborships here are the 2-byte and the 4-byte ASN. So router BGP 65100 on the left, and then router BGP at 65536 on the right, which is the 4-byte ASN format. And then also on the leaf configurations, we can see here too, we do have replace RT-ASN for the border VTEP, as you see here on the left-hand side, and then corresponding to 7777, which is Border Gateway 2 on the right-hand side for both of these two fabrics. And so we'll just kind of skip through this demo a little bit. Okay, so we're just going to dump the EVPN configuration for all the devices. And you can see that we've specified the route target auto mode legacy that's been discussed already. And then as well, since this is EVGP, we've also got the the tunnel bridging mode here from IBGP to EBGP on both the border gateways. That would be required for this configuration as well. And then the corresponding VLAN 10 and VLAN 20 for the EVPN configurations on both sides. So this is the routed L3 VNI use case. Okay, and so now we're just looking at the VRF configuration here. And so this is the new 10.16 command, the route target export and import auto VPN. So we specify the unique route distinguisher, and then we have this configured, on each device, as well as a unique virtual MAC that you see here. This is required for the environment. So we want to specify this across all the devices and keep the configurations unique. Some of these would match themselves if they were VSX, but they're unique since these are just standalone routers. And so just dumping the SVI on both sides. So for leaf 1, it's VLAN 10, and then also VLAN 20 on leaf 2. Okay, so now we're going to just check connectivity between each of the devices. We're actually just going to ping the gateway to start with. So we see that that's successful. We can see BGP is established across the environment. So we haven't really proved any communication across the fabrics yet, but we do say that we've got BGP sessions that are established in a healthy state. And now we're just looking at the VTEPs to see if we've got tunnels that are up and running. So we see the tunnel for VNI 10 corresponding to VLAN 10, and then also the L3 VNI 1000. And we see the tunnels for the correct VNIs pointing at the border gateways. And this is where we're just dumping the EVPN EVI output. And so kind of as we've already discussed, we show that it's been rewritten as 65100:10 for the L2 VNI, and then also the 65100:1000 for the L3 VNI. And the uniqueness on the right-hand side is the ASN is the 65536, which is the 4-byte format. But for interoperability, we've rewritten it as 23456:20 and 23456:1000 per the standard. Okay, now we're just going to make sure that we can communicate across the fabric. So VM1 is pinging VM2 and then vice versa. So we've got communication going across the fabric successfully. And when I say fabric, I mean fabrics. There are 2 fabrics here. And this is our troubleshooting command. We're just using the show BGP L2 VPN external community command to make sure that we are seeing that the route targets are getting rewritten with the correct ASN number corresponding to the MAC and IP entries that you see there for route type 2. And that's all looking good. Okay, so now what we're going to do is just go in and we're going to remove the route target auto mode legacy command so that we're using the 4-byte suffix, and you'll see what that looks like in a moment. And so this is specific to EVPN itself. So we're going to do that on each side, and then once we're done there, we'll take a look at the show EVPN EVI command again. And you see as we're doing this, we're not disrupting any communication at all between the 2 VMs. And then, as I mentioned, for consistency, we should also do this on the borders. I believe we'll change this in a moment, but you see now that the, so for L2 VNI 10, you can see that we've got a 4-byte suffix there now, but only on leaf 1, not on leaf 2. And where we're going to go to border gateway 1, make the change there. And the reason this isn't really all that applicable is because we're using the L3 VNI for communication here. As you can see in both cases, that hasn't really changed. That's what we had existing before. So we changed them across the board. You can see we've got the EVP and EVI output on both of the borders. And so that still is all looking like we'd expected. We didn't actually make any changes in this regard because, again, we're using the L3 VNI for communication. And that's pretty much it for this demo, the L3 VNI auto route target import. Okay, and so for this is the second demo that we're going to show you. And so it's pretty much the same as the prior demo, except what you can see that we've got here at the bottom is that we've got the two VMs are now on the same subnet across the two fabrics. So 10.11.110 and 10.11.111 for VM2. And so we're going to show communication going back and forth between the two, still using, again, so we still have the 2-byte and the 4-byte ASNs in this environment, and we'll show you what has to be configured to get that to work correctly. Just as the prior demonstration, the BGP configuration, none of that's really changed. We still are using the replace RT-ASN feature, as we can see. And so we've got the auto mode legacy feature enabled on across all the devices in the environment. And we're just showing that the tunnels are up and running, corresponding to each of the border gateways, which is expected. And then the same is true for the border gateways. They're each connected to each other as well as to the opposite border gateway. And we're just dumping the EVP and EVI output, as you can see prior. So we've got VNI 10. This is all as we'd expect to see with the auto mode legacy configuration. And you can see that we're able to ping from VM1 to VM2 and vice versa. So now we're not using the L3 VNI, we're using the L2 VNI to communicate across the fabrics. And we can see that the correct ASN is getting rewritten in both cases. Corresponding to the IP and MAC entries for the 10.11.10 and 10.11.11 VMs. And this is where we're going to take out the route target auto mode legacy command, or disable the feature from the EVPN configuration syntax. Okay, I'm doing this on both leave 1 and leave 2. And you can already see that our pings have stopped there. And we're just going to, like we mentioned before, try to maintain consistency. So we're going to make sure that this is configured the same across all the devices in the environment. So covering border gateway 1 and border gateway 2. Okay, so we just demonstrating we've got it configured the same across all the devices in the environment. And the pings still are not working, and the reason being, we'll see with the EVPI output on both sides. Okay, so now since we're using the L2 VNI, we see we've got the 4-byte suffix on one side, but not the 4-byte suffix on the other side. So these two things need to match, and they do match when you configure the route target auto mode legacy. So this is required when you're doing a L2 VNI stretch across fabrics, which is why this isn't working with the 2-byte ASN and the 4-byte ASN. If you just had the 2-byte ASNs on both sides, then this wouldn't be a problem at all. But since we've introduced support for the 4-byte ASN, this is not going to work. You have to have the route target auto mode legacy feature enabled for this to work successfully. So just keep that in mind. Just wanted to show you that. We did mention that in the slide presentation as well. So thank you for attending today's session. If you're not familiar with our Airheads community, I'd just like to encourage you to go out and scan the QR code and join the Airheads community today. There's a lot of helpful content that we produce for the Airheads community. All these videos that you see here in the presentations are available out at the community. So just encourage you to join if you're not a member already today.